S. presents Educational Video Lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
What will happen to the light when it transfers from one media to another media? So we know that light waves are the transverse wave. So there must occur the properties of reflection as well as the transmission. And what is a path followed by the light when it falls on some media? So that path that can be explained in terms of some principles. So that will we understand in the upcoming topic.
If you want to study this topic in detail, refer to the book by S. Publishing. Link is provided in the description box.
Myself, Dr. Narinder Kaur. Welcome to S. Academy. Now we will understand how the light follows the path. Now, so that can be explained in terms of the Fermat's principle. Now, what is the Fermat's principle? So, according to this principle, it states that light follows a path of its quickest time. That means, what is a path followed by light? Now, when you pass the light from one point to the another point, and some mirror is placed over there, we know that some portion of the light is get reflected and some portion of the light that will be get transmitted. So what path that will be followed by the light? So where it has taken the smallest time or the quickest time, in that path that must be followed by the light. So such kind of principles that is known as a Fermat's principle. So which states that the light follows a path of the quickest time. So this is an important principle. Fermat principle is also known as a principle of least time. So that means when the light is traveling from one point to the another point. So that means light is traveling energy or the information is passed from one point to the another point. The information is passed from one point to the another point in the shortest time period. That principle is given by the Fermat, and that principle is known as Fermat's principle. But firstly, it is understood that there is no relationship exists between the angle of incident and the refraction. Firstly, it was given that means the light does not follow the quickest time. In before the 16th centuries, we are not able to explain the path of light. But in order to explain the path of light, we are taking the Fermat's principle of least time. So firstly, it is taken that the refractive behavior of light has been a source of study, and since there is no simple relationship, because the relationship between the angle of incidence and the refraction that cannot be determined. So firstly, we will understand what are these two terms, refraction and incident. Means if this is a mirror over here, it's both of the sides they are get polished, and when the light is incident on it, so this is some light and that is the angle of incidence. We know that at that point some portion of the light get reflected. So this portion reflected means the light will change its phase, and that portion, this is the incident light and that is the reflected light, and some portion of this light that get transmitted or refracted. So this portion is get refracted. Refracted means the transmitted light. The transmitted part of the light that is known as a refracted path of the light get refracted. So now if this is the angle of reflection, now that is the angle of transmission or the refracted. Now what is the relationship between this angle of incidence and this angle of refraction? So there is no relationship between the angle of incidence and the angle of refraction. That means we are not able to get the path followed by the light when it is reflected or when it is incident on some mirrored surface or polished or the semi-polished surface. If mirror now, the light is get reflected, that means if one surface is fully polished and one surface is a semi-polished. So when the one surface is semi-polished, so some portion of the light that will be get reflected and some portion of the light that will be get refracted. So we are not able to define the relationship between angle of incidence and the angle of transmitted. Now this angle, the relationship between these two angles, that is given in 1621 by the Snell's. So there comes a Snell's law again in order to explain the reflected light and the refracted light. So this is given by Snell. So before 1621, it is seen that, or it thinks that, it is thought that there is no relationship between the angle of incidence as well as angle of refraction. So there is no relationship between them. So this is a term incidence and the reflection. So there is no, the angle between, the relationship between the angles, that cannot be determined over here. While in 1621, Snell's determined that it is a signs of angle of incidence and the refraction that are maintain a constant ratio for the given pair of media. Now what does it mean? So in the Snell's, it is defined as when this media is fixed over here and we are placing one mirror over here and the light is incident, some portion of the light is get reflected and some portion of the light that is get refracted. Now we want to define the angle relationship between the angle of incidence and the angle of refraction. So according to Snell's, the ratio of the angle of sines of the angle. So that means instead of any angle, we are taking the sine angles. That means the sine I by sine T, or you can see that theta R, if this is the angle of refraction. So now sine I is the angle of incidence. This ratio, that is taken as constant always. That means when the angle of incidence is changed, automatically the angle of refraction. So here R is a refraction over here. So that means the angle of refraction, that is also get changed because their ratio that will always remains constant. So this is a Snell's law in order to define the relationship between the angle of incidence and the angle of refraction. So this is best, we can also, depending upon that, we can calculate the angle of reflection also. That means a Fermat's principle that can be applied over it. So Fermat's principle that can be applied, by which we can calculate the path of the light followed. Means when we want to calculate what is the path which is followed by the light, we must be aware of what is their angle, angle of incidence, reflection and the refraction, and what is the relationship between these angles. So that can be calculated over here. Now the basic applications of the Fermat's principle are that in the homogeneous medium, light rays are rectilinear, that is in any media where the index of refraction is constant, light travels in a straight line. So now what does that mean? We know that there occur the two kind of media is there. One is a homogeneous medium and second one is a heterogeneous medium. So the homogeneous medium is so this is an important point, means all the particles are distributed at each and every point with the same density. So density of the particles in the given area that will be constant. Such kind of media is known as homogeneous media. So means if the particle density is constant in this media, automatically we know that the light when enters through this media, it will suffer continuously reflections and refraction. So after that, when light enters to this media, so this here from the particle, if they are homogeneously distributed over here, that means the particles are distributed over here homogeneously. So there are some particles which are equally spaced over here, and now the light will suffer over here continuous, or you can say that in the proper way reflection and transmission. After that the light will get transmitted over here. So this implies when light has to pass from homogeneous medium from one point to the another point, the straight line path of the light will be followed. That means if the light, incident light is a straight line, then again the transmitted light is also having a straight line path. So path of the light that never be changed over here. So this is a first principle of the Fermat's application of the Fermat's principle, according to which the path of the light remains constant when it is traveling to the homogeneous medium. Now, when the particle or the light is traveling from the heterogeneous medium, then what will happen? What is the heterogeneous medium is? At some places, the density of the atoms or the particle that will be very high, and at some places, density that will be very low. So, this kind of media that is known as a heterogeneous media. Now, that means when the light enters over here to this media, so here it will suffer the multiple reflection. Again, here there is very less reflection. Again, it will suffer multiple reflection. So, that means the light in this case does not follow the straight line path. Means when the straight line light is gets incident, the transmitted light will have the different path. So, the different path that will be followed by the light. So, in this case, the path of the light that will be changed. That means now when the uniform media is there, that means the light will follow the quickest path. How quickly it can passes through that media. So, that is the Fermat's principle. But when the large density is there, the light that will be get trapped in this media. So, due to homogeneous medium, heterogeneous medium, the light due to large reflections will occur in the one region and small reflections will occur in the another region. So, that will disturb the path of the light over here. So, that means, so this is the first Fermat's principle, according to which in a homogeneous medium, the light rays are rectilinear. Rectilinear means they will follow the same path. When the straight line light is incident, the output, in the output when the light is get transmitted, we are again getting a light with the straight line path. Means angle of incidence and the reflection and the angle of refraction, they never get changed. They will always remain the same when the light incident on the medium and it will get transmitted back from the media. So, in this case, the angle of refraction is also remains constant. A homogeneous medium means angle of refraction means it will define the index of refraction, it will define and the number of particles per unit area. So, number of particles per unit area that will remain constant, that is same throughout the media. So, automatically the light will travel in the straight line path. Second is the angle of reflection of the surface is equals to angle of incidence, and that is a law of reflection. Now, what does it mean? That means when there is a, now the light is traveling in the same media, so that means, now, so in this case we know that the light is incident on it. So, from here the light get reflected back. So, now per surface the medium is same. So, the angle of incidence is I, and if this is the angle of reflection. So, what is the important point over here? The angle of incidence that is equals to angle of reflection. So, both are same in this case. When they are same to each other, so in that case the light will follow the rectilinear path. That means light follows rectilinear path. It will always travel to the straight line path. So, you can also see that the phase of incident light and the reflected light that will be same. So, an angle of incidence that must be same to the angle of reflection. So, this is known as laws of reflection. This is known as laws of reflection, and that is given by Snell's law. So, depending upon Snell's, it is clearly understood what is the angle of incidence and what is the angle of reflection over here. How the light follows the path, quickest path when it travels from one media to the another media, or when it is get reflected back or transmitted to the one mirrored surface. So, such kind of things that is explained by very well by the Fermat's principle. So, Fermat principle basically it is applied to the light waves by which, and Fermat principle is applied to the light waves and how the light travels in the one media, and it is explained by the Snell's. According to Snell's, the light follows a rectilinear path, and also the laws of, according to law of reflection, the angle of incidence is same as that of angle of reflection. Now, we will take a short break. So, we understood what is the Fermat's principle, how it is applied to the laws of reflection in terms of Snell's law. And after the break, we will understand what is the laws of reflection and how they are applicable in order to calculate the traveling of light waves in the given media.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S. Chand Academy. Now we know that the light is traveling from one media to the another media. So some portion of the light that is get reflected, some portion of the light that is get transmitted. So for the reflected light, the waves are known as reflected waves. And what are the laws for this reflected waves that we will calculated in this, we will understand in this topic. So now let us begin with the laws of reflection. Firstly, what is a reflection? So reflection, that is a spreading of light, or that is a reflection is a when the light is incident on some media. So it is get reflected back. So that kind of things are known as reflected waves. The waves, the incident wave, when it is reflected back, that is known as reflected wave. So laws of reflections are, so the laws of reflection defines that upon the reflection from a smooth surface, the angle of reflected ray is equal to angle of incident ray. So this is a Snell's law. That means when the surface is very smooth, so that means on this smooth surface, when the light is incident, it gets reflected. So this is the angle of reflection. And if this is a perpendicular over here, so along the perpendicular, depending upon the density of the media which is get separated over here, if the mirror is placed over here, so depending on the density of the medium, some portion of the light that is get refracted over here. So some portion that get refracted. So this is a reflected light. And that is a incident light. So what is a Snell's law? They both of these angles, they are equal to each other. So that means angle of incidence that must be equal to angle of reflection over here. So that is a law of reflection. And that means when the light is incident on the smooth surface, in that case, the angle of incident wave that must be equal to the angle of reflected ray. So with respect to the normal to the surface is to the line perpendicular to the surface of the point of contact. Means these angles are taken with respect to normal. So these are the normal over here. So on any incident surface, the normal is taken over here. So with the normal to the surface, these angles are taken over here. And these angles are same in this case. Second is a reflected light. This is the first law. Second is the reflected ray is always in plane defined by the incident ray and normal to the surface at the point of contact of the incident ray. Means the both of the way, incident ray and the reflected ray, they are in the same plane. So that is clearly seen over here. These both rays, reflected rays and incident ray, they both are in the same plane, while the refracted wave or the transmitted wave, that is in the another plane. So incident wave and the reflected wave, they are in the one plane. If this is a one plane, so they are in the one plane, while this reflected wave, that is in the second plane. So these are get separated from the reflected light. So these are the two laws of reflection. First is the angle of incidence that must be equal to angle of reflection, that is according to the Snell's law. So in order to define the reflection of light and the refraction of light, their angle must be same. This is the first law. And the second law is what? Reflected light and the incident light, they must be in the same plane. So they are in the same plane. Now the laws of reflection that can be defined as the principle when the light rays falls on the smooth surface. So this is the important point over here, because when the light falls on the irregular surface, so there with respect to reflected light, it is get reflected from the each and every portion. So automatically the reflected light will have the different angle to the incident light. So when the surface is smooth, in that case only it is possible to the angle of incidence to be equal to the angle of reflection. So they are same. So the angle of reflection, that is equal to angle of incidence, and also the incident ray, the reflected ray, and the normal to the surface all lies in the same plane. So that means incident ray, normal to the plane, and reflected ray, all these lies in the same plane. So these are the laws of reflection. Now, what are the types of reflection? So there are the two types of reflection. One is a regular reflection and second one is a irregular reflection. Now, as the name indicated, regular reflection means when the surface upon which light is incident, it is a regular surface. Or you can say that the plane surface. So smooth surface is there, then the reflection takes place from such surfaces, that is known as a regular reflection. So the plane mirrors with a smooth surface that will produce this type of reflection. So that means the reflection is of two types. One is a regular reflection and second one is a irregular reflection. So the regular reflection is defined as when the plane mirrors with a smooth surface, they will produce this type of reflection. In such cases, the image is clear and very much visible. The image produced by plane mirrors are always virtual, and that is they cannot be collected on the screen, because when the smooth surface is very smooth, so in that case the same light is get incident. So that means in such cases the light is, when the incident light is same as that of the reflected light. So in that cases, that means we are not able to see the image. Image is seen when there some portion of the light that is get transmitted. So in that case, we are able to see the images. So for the regular surface, when the smooth surface is present over there, the incident light is there. So in one plane, the reflected light means they both are same to each other. So in that cases, and we know that the phase is different. So if we think in terms of interference pattern, so that means the incident light is with this angle. So this angle, if this is with a 0 degree angle, and the reflected light that is with a 180 degree angle. Now when they superimpose on each other, because they are in the same plane, so in the resultant we will get the constructive interference, then no light will be there. So that means we are not able to see the image of the object. So in order to see the image of the object, some roughness in the surface that must be there. So then in that case we are able to see the image of the surface. So clear an image that can be possible. Now next is a irregular reflection. What is the irregular reflection? That means surfaces that are not smooth in this case. So consecutive, the large number of multiple reflections are takes place, and due to this multiple reflection, at the end we will get the resultant light and the irregular shapes of the bodies that can be seen in this case. So hence that means there must be a color diffuse reflection that will be helped to see the object, and that is responsible for the ability to see the objects. That means, now what does it mean? Means when there is an irregular surface. So irregular surface, what does it mean? Means the surface is like this. So there are the crust and troughs on the surface. Now when the light is incident at this point, so in this point at some portion the light is get reflected, again it is get from some portion is get transmitted, again it get reflected, again at this point what will happen? So the light is get transmitted, again it will get reflected from here. Now when the light is followed at this point, so in this case it will follow the different path. So that means the reflected light. So there occur multiple reflections. Some portion of the light that get reflected, some portion of the light get refracted. So from the irregular surface, there occur multiple reflections and the refraction. Due to multiple reflection and the refraction, we are able to see each and every point of the object. That means in order to see each and every point of the object, it is clear to give the irregular surface. So by the irregular surface, properly image of the object that can be seen. So from the irregular objects or the irregular reflections, you can see that the irregular reflections, they are responsible in order to see the objects. That means when the irregular surfaces, they are illuminated with the light, we can properly see their image, while for the regular surface, virtual image is seen. means that image is not real over there. So the real image is possible when we are see the irregular reflections instead of regular reflections. So this is the laws of reflection. Now the laws of refraction formula, how you can define this. So if this is the incident wave and that is the angle of incidence over here with respect to normal, the angle that can be calculated. Now this is the normal over here and that is the angle of reflection. Now if you can take this is the I also and that is the R also. Here if the theta 1 that is taken as the angle of incidence with respect to normal. Angle of reflection theta 2 with respect to normal. So now what is the laws of reflection formula? So first is the sine theta I that must be equals to theta R. So this is the first law according to which the Snell's explain that the theta I that must be equals to theta R in order to see the proper surface. Now what is this here? So this is the polished mirror or this is a mirrored surface which is taken over here in order to see the proper image of the object. Means when this one surface of the mirror that is get polished over here. So that means when this surface of the mirror is get polished, so whole of the light that is get reflected back, no portion of the light get transmitted. So in this case, this is the incident ray and that is a reflected ray with respect to normal. Now all these components, they are lying in the one plane and we are properly and we are here able to see the proper image of the object. So that can be understood in this case. So now when the theta I, so if there are some numerical problem and the theta I angle is given to us, if this is a 50 degree and we have to calculate the angle of reflection. If the light is incident, at an angle of 50 degree, then what will be the angle of reflection? That means at what angle the light is get reflected back from the surface. Now that is very clear. Now when we are applying the Snell's law over here, so what is the Snell's law of reflection? Now according to Snell's law of reflection, we know that this theta I and that must be equals to theta R, and how we can represent this graphically. So theta I, that angle of incidence is 50 degree which is equals to theta R. That means the angle of reflection that must be same, and the one important point is that what are the conditions when theta I is equals to theta R. So that means in that case, firstly the Snell's law is followed. And the light has to propagate in the rectilinear path. Means when the light is following the rectilinear path, in that case theta I that must be equals to theta. Then how we can represent it graphically? So graphically it can be represented like this. So what are the conditions behind this? Normal, incident wave, reflected wave. They all must be in the one plane. Means normal, the incident ray and the reflected ray. All these three must be in the one plane. And the second condition, light must follow, that must follow the rectilinear path. What is the meaning of rectilinear path? Means it will travel in the straight line over here. So if this angle theta I that is equals to 50 degree, that is an incident wave, and this is a normal and that is a reflected over here, then this theta R that must also be equals to 50 degree. So all these are the angles of reflection by which we can calculate the propagation of the light over here. So now we understood over here what is the reflection of the light, and how we can properly see the objects when there occur the irregular reflections instead of regular reflection. Means irregular reflection means when there occur multiple reflections of the object from the one point. So when the multiple reflections will take place, all these will superimpose on each other to give us the one result or the proper image of the object. Thank you.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.